Hello there, welcome to this tutorial. The topic is system of linear equations and the method is Cramer's rule. My name is Abdurrahman Umar. Please subscribe to our YouTube channel Uninab Resources and like this video. We have a lot of more videos out there. Let's go. Problem 1. Solve the system of the equations x1 plus 2x2 minus 3x3 is equal to 3. 2x1 minus x2 minus x3 is equal to 11. 3x1 and 2x2 plus x3 is equal to negative 5. So we are going to form four matrices here. We let the coefficient matrix be delta, x1 matrix be delta 1, x2 matrix be delta 2, and x3 matrix be delta 3. So we start with the delta matrix. Here the elements of the first row are the coefficients of the variables in equation 1. So the equation 1, the x1 has coefficient 1, x2 has coefficient 2, x3 has coefficient negative 3. And for row 2, the elements are the coefficient of x1, x2 in equation 2. We have a 2, negative 1, and negative 1. The third row, we have the elements to be 3, 2, and 1. So we have generated the coefficient matrix, which is delta. To get the x1 matrix, for your information, the column 1 represents the coefficient of x1, column 2 represents the coefficient of x2, column 3 represents the coefficient of x3. So to get x1 matrix, we shall remove column 1 and replace it with the constant column. So the constant column shall be 3, 11, and negative 5. In the x1 matrix, which is delta 1, we remove the first column and replace it with the constant column, which is 3, 11, and negative 5. So we still maintain the second column and the third column. So that will be 2, negative 1, 2, negative 3, negative 1, and 1. In the same way, to get the x2 matrix, we remove the column 2, since column 2 is a collection of coefficient of x2. We remove column 2 and replace it with the constant column. So in that case, we still maintain column 1. So we maintain column 1. So we replace column 2 with 3, 11, and negative 5. And we still maintain column 3. So we are done with generating the element of delta 2, which represents the x2 matrix. x3 matrix is said to be delta 3. Here we are going to maintain column 1, column 2, and replace the column 3, which is the collection of the coefficients of x3 with the constant column. So we have it as a column 1 maintain, column 2 maintain, and column 3 we have a 3, 11, and negative 5. Now the essence of generating all these matrices is to find their determinant. After finding their determinant, we shall use it to find the values of x1, x2, and x3. So let's go. We start from the determinant of delta. The method of finding the determinant, as shown in our determinant tutorial, we have to assign positive to the first column, negative to the second column, and positive to the third column. So we pick the first element in the first column. Since it is positive, so we delete the first row and the first column. We are now left with negative 1, negative 1, 2, and 1. This is a determinant of a 2 by 2 matrix. So we shall evaluate that later. Then we go to the second column. We have the first element in column 2 to be 2. So we are going to have it as negative 2. Delete the column, delete the row. So we are now left with 2, -1, 3, 1. And we go to the third column. The sign of the third column is positive, and the first element there is -3. So you have plus -3. Delete the column, delete the row. We're left with 2, -1, 3, and 2. So we are done with the first, second, and the third columns. Evaluate the determinants of these 2 by 2. So we have in the first one, we have 1 outside. -1 times 1 gives -1, minus 2 times -1 gives -2. So we go to the second one, the middle one, that is -2 is outside. We have -2. 2 times 1 gives 2, minus 3 times -1 gives -3. So plus minus gives negative. So we have 2 times 2 gives 4, minus 3 times -1 gives -3. That's minus 3. So here we now remove the inner bracket first. So here 1, this is -1. Negative times negative gives positive. So we have a plus 2 there. Here what we have outside is -2. So we have 2 here. Negative gives positive. That's plus 3. We have -3 outside. This is also 4. Negative gives positive. So we now evaluate. -1 plus 2 gives 1. 1 times 1 gives 1. 2 plus 3 gives 5 times -2 gives -10. 4 plus 3 gives 7 times -3 gives -21. So evaluating this, we have a -30. So the determinant of delta, that is the coefficient matrix, is -30. So we go ahead to find the determinant of x1 matrix, which is delta 1. So to do that, again, we assign positive to the first column, negative to the second column, and positive to the third column. So here again we pick the first column. Picking the first column, the sign there is positive, and the first element there is 3. So we have a 3 there. Delete the row, delete the column. We are left with -1, -1, 2, and 1. We go to the second column. The sign there is negative, and the first element is 2. So we have -2. Delete the column, delete the row. So we have 11, -1, -5, and 1. So here we are done with that. We go to the third column. Going to the third column, the sign there is positive, and the first element is -3. So we have plus -3. Then delete the column, delete the row. We are left with 1 and a -1. So we now have -5 and 2. So we are done with that again. We now evaluate the 2 by 2 determinants we have generated. So the first element outside here is 3. We have the elements outside here to be 3. -1 times 1 gives -1, minus 2 times -1 gives -2. So we go to the middle. We have -2 outside the determinant. So we have 11 times 1 gives 11. Minus -5 times -1 gives +5. So there we are done. Positive negative gives negative. So we have -3 there. 11 times 2 gives 22. Minus -5 times -1 gives +5. So we now remove the inner bracket only in the first part. So we have a 3. This is -1. Negative gives positive, so that's +2. So we maintain the rest. -3, 22 minus 5. So we now evaluate. -1 plus 2 gives 1 times 3 gives 3. So 11 minus 5 gives 6 times negative 2 gives negative 12. 22 minus 5 gives 17 times negative 3 gives negative 51. So we now have our answer as negative 60. Simplifying this, we have negative 60. That is the determinant of x1 matrix, which is delta 1. So the delta 1 matrix has a determinant negative 60. Go to x2 matrix, which is delta 2, and find the determinant. We assign in the first column positive, negative, positive. So we pick the first column now. The first element there is positive 1. So we have a 1. Delete the row, delete the column. We have 11, negative 1, negative 5, and 1. We go to the second column. The sign is negative, and the first element is 3. So we have a negative 3. Delete the column, delete the row. So we are left with 2, negative 1, 3, and 1. In the third column, the sign is positive, and the first element there is negative 3. So we have plus negative 3. Then we delete the column, delete the row. We are left with 2, 11, 3, and negative 5. So again, we evaluate these determinants. So the first one, we have minus outside. 11 times 1 gives 11. Minus negative 5 times negative 1 gives positive 5. Then the middle one, we have negative 3 outside. 2 times 1 gives 2. Minus 3 times negative 1 gives negative 3. Plus and minus here is minus. So we have 2 times negative 5 gives negative 10. And minus 3 times 11 gives 33. We remove the inner brackets here and there. So we have 1, 11 minus 5. This is negative 3, 2 plus 3. That's negative, negative gives positive. So 2 plus 3 is negative 3, negative 10 minus 33. So we evaluate. 11 minus 5 gives 6 times 1 gives 6. So this is 2 plus 3 gives 5 times negative 3 gives negative 15. Negative 10 minus 33 gives negative 43. Multiplied by negative 3 will give us positive 129. So evaluating this, we have a 120. So the x2 matrix has determinant 120. So we proceed to x3 matrix and find the determinants. So the determinant of delta 3, here we assign positive, negative, and positive. So we pick the first element in the first column, which is positive 1. Then delete the row, delete the column. We are left with negative 1, 11, 2, negative 5. So again, we are going to the next column, and the sign there is negative. So the first element is 2. So we have negative 2. Delete the column, delete the row. So we have a 2, 11, 3, negative 5. And the last column, we have a positive 3 there. So we have a plus 3. So delete the column, the 3 belongs, and the row it belongs. So we are left with 2, negative 1, 3, and 2. So we evaluate these determinants. So the first one here, 1 is outside. Negative 1 times negative 5 gives 5. Minus 2 times 11 gives 22. This is negative 2. 2 times negative 5 gives negative 10. Minus 3 times 11 gives 33. This is positive 3 here. 2 times 2 gives 4. Minus 3 times negative 1 gives negative 3. We now remove the inner brackets here and here. So we still maintain this. 5 minus 22, negative 2. Then this is negative 10 minus 33. This is 3 into 4 plus 3. Negative negative is positive, so we simplify this. 5 minus 22 gives negative 17 times 1 gives negative 17. Negative 10 minus 33 gives negative 43 times negative 2 will give us positive 86. 4 plus 3 gives 7 times 3 gives 21. So evaluating this, we have a 90. So the X3 matrix has determinant 90. So we are done finding the determinant of the 4 matrices we have. So we now go ahead to find the value of x1. To get the value of x1, it is determinant of delta 1 over the determinant of delta, which is negative 60 divided by negative 30, and that gives 2. So for x2, it is determinant of delta 2 divided by the determinant of delta, which is 120 divided by negative 30, and that gives negative 4. And lastly, to get the value of x3, it is determinant of delta 3 over determinant of delta, which is 90 divided by negative 30, and that gives negative 3. We have done justice to this problem 1. So problem 2, solve the system of the equations 2x plus y minus 2z is equal to 9, 3x minus y plus z is equal to 3, x plus 2y plus 3z is equal to negative 2. So we start again by generating 4 matrices. So and we let the coefficient matrix be delta, x matrix be delta x, y matrix be delta y, and the z matrix be delta z. So again we form the first one, which is the collection of the coefficients of the variable x, y, and z. The first row will be the collection of the coefficient of x, y, and z from the first equation. That's going to give us 2, 1, negative 2. The second row we have a 3, negative 1, and 1. And the third row we have the coefficient 1, coefficient 2, coefficient 3. So we are there. We go to the x matrix, which is delta x. The first column is the collection of coefficient of x. You can see 2, 3, 1, 2, 3, 1. And the second column is the collection of coefficient of y. 1, negative 1, 2, 1, negative 1, 2. The same thing, the third column is the collection of coefficient of z. That's negative 1, 3. So to get the delta x, which is the x matrix, we remove the first column, which is the collection of the coefficient of x, and replace it with the constant column, which is 9, 3, and negative 2. So we have a 9, 3, negative 2, and we still maintain the remaining 2 columns. So that's 1, negative 1, 2, negative 2, 1, 3. Then we go to the y matrix, which is delta y. Again, we are going to remove the collection of the coefficients of y, which is the second column. We still maintain our first column. The second column will be replaced by 9, 3, negative 2, 9, 3, negative 2, and we maintain our third column. Then the z matrix, which is delta z, in the same way we maintain the first 2 columns. The first 2 columns are maintained. The third column will be constant matrix, 9, 3, and negative 2. We now calculate the determinant. So determinant of the first matrix, this is positive, negative, positive. We pick the first element in the first column, which is positive 2. Delete the row, delete the column. We are left with negative 1, 1, 2, 3. Then we go to the second column. That's negative 1. Delete the column, delete the row. 3, 1, 1, 3. Then we go to the third column, that is positive and negative 2 plus negative 2. So we delete the column, delete the row. We are left with 3, negative 1, 1, and 2. So here we go ahead to evaluate this determinant. So we have 2 outside. Negative 1 times 3 gives negative 3, minus 2 times 1 gives 2. So we have a negative 1 here. 3 times 3 gives 9, minus 1 times 1 gives 1. Then positive negative gives negative. 2 times 3 gives 6, minus 1 times negative 1 gives negative 1. So here we have 2. Remove this inner bracket. This is negative 3 minus 2. This is negative 2, 9 minus 1, negative 2, 6. Negative gives positive 1. So we simplify. Negative 3 minus 2 gives negative 5 times 2, negative 10. 9 minus 1 gives 8 times negative 1 gives negative 8. 6 plus 1 gives 7 times negative 2 gives negative 14. Simplifying this, we have a negative 32. So the delta matrix, the coefficient matrix, is a negative 32. We go ahead to find the determinant of the X matrix, which is delta X. So we assign positive, negative, and positive. So pick the first element here in the first column. That's positive 9. Delete the row, delete the column. We have negative 1, 1, 3, 2, and 3. So we go to the second column. This is negative 1. So we have negative 1 there. Delete the column, delete the row. We have 3, 1, negative 2, and 3. So we go to the third column. This is plus negative 2. Delete the row, delete the column, delete the row. We have 3, negative 1, negative 2, and 2. So we now evaluate these determinants. So we have 9 is outside. Negative 1 times 2 gives negative 3, minus 2 times 1 gives 2. We have negative 1. 3 times 3 gives 9, minus negative 2 times 1 gives negative 2. Negative, positive, negative gives negative 2. 2 times 3 gives 6, minus negative 2 times negative 1 gives 2. We remove the inner bracket. That's 9. This is negative 3 minus 2. This is minus 1. 9, negative gives positive 2. This is negative 2, 6 minus 2. We simplify. Negative 2 minus 2 gives negative 5 times 9 gives negative 45. 2 plus 9 gives 11 times negative 1, negative 11. 6 minus 2 gives 4 times negative 2 gives negative 8. Simplifying this, this is negative 64. The delta X matrix is equal to negative 64. And here we have the determinant of delta Y. So we assign positive to the first column, negative second column, and positive third column. We pick the first column. The sign there is positive, so we have plus 2. Delete the row, delete the column. So I left with 3, 1, negative 2, 3. Then we go to the second column. This is negative 9 there. So we have negative 9. Delete the column, delete the row. We are left with 3, 1, 1, 3. So the third column, this is plus negative 2. Delete the column, delete the row. We are left with 3, 3, 1, and negative 2. We then evaluate the determinants we have in there. So we have 2 here. 2. 3 times 3 gives 9, minus negative 2 times 1 gives negative 2. This is negative 9. 3 times 3 gives 9, minus 1. So 1 times 1 is 1. This is positive, negative gives negative 2. 3 times negative 2 gives negative 6, minus 1 times 3 gives 3. So removing the inner bracket, I have a 2, 9, negative negative gives plus 2. We have negative 9 outside, so this is 9 minus 1. So this is negative 2 outside. This is negative 6 minus 3. We simplify. 9 plus 2 gives 11 times 2, 22. 9 minus 1 gives 8 times 9 gives negative 72. Negative 2 minus 3 gives negative 9 times negative 2 gives positive 18. Simplifying this, we have negative 32. So the determinant of delta y is negative 32. Now we go to the last matrix, finding the determinant. We have positive here, negative, positive. So the first column, the first element there is 2. Since it is plus 2, delete the row, delete the column. We have a negative 1, 3, 2, negative 2. Go to the second column. There is negative 1. Delete the column, delete the row. We have 3, 3, 1, negative 2. And the last column is positive 9. Delete the column, delete the row. We have a 3, negative 1, 1, 2. We now evaluate the determinants we just created. So 2 is outside. So we have 2 outside here. Negative 1 times negative 2 gives positive 2. Minus 2 times 3 gives 6. Then this is negative 1. 3 times negative 2 gives negative 6. Minus 1 times 3 gives 3. This is positive 9. 3 times 2 gives 6. Minus 1 times negative 1 gives negative 1. So here we have a 2. Removing the inner bracket. This one has no inner bracket. So we have 2 minus 6. This is minus 1. Negative 6 is negative 6 minus 3. And here this is positive 9. 6 minus minus gives positive, so that will give us plus 1. 2 minus 6 gives negative 4 times 2 gives negative 8. Negative 6 minus 3 gives negative 9 times negative 1 will give us plus 9. 6 plus 1 gives 7. Times 9 gives 63. So simplifying this, we have a 64. The determinant of delta z is 64. So we now go ahead to find the values of x, y, and z. So the value of xy is delta z, is delta x divided by. So the value of x here is determinant of delta x, that is the determinant of x matrix, divided by the determinant of delta, which is negative 64, divided by negative 32. That gives 2. Then for y, determinant of delta y divided by the determinant of the delta, that's negative 32 divided by negative 32, which gives 1. And for z, the determinant of delta z divided by the determinant of the delta, 64 divided by negative 32, which gives negative 2. That brings the tutorial to an end. Thank you for watching this video. I hope you love it, and if you do, please subscribe to our YouTube channel at Oninab Resources. Hit the like button for this video. Thanks for watching, and bye for now.